Hello everyone and welcome back to my channel. We have been discussing the methods to estimate heritability and this is the fourth video on this topic. In first video I talked about the methods to estimate broad sense heritability and methods to estimate narrow sense heritability. In that video I also provided an example on estimation of broad sense heritability using twins data. In part 2, I provided an example of estimation of narrow sense heritability using regression of offspring on one parent. And in part 3, I provided an example of estimation of narrow sense heritability using regression of offspring on mid-parent. So if you didn't watch these videos, I would recommend you to watch them before watching this one to better understand the concepts of methods to estimate heritability. So in this video, I will talk about the estimation of narrow sense heritability using correlation between relatives. So before moving towards our today's topic, I want to give you an overview about the methods to estimate narrow sense heritability. So the first method I talked about was the offspring parent regression method. The second method is the estimation of heritability using correlation between relatives. The third method is analysis of variance or intra-class correlation. And the fourth method is the restricted maximum likelihood method. So let's start our today's topic, that is estimation of narrow sense heritability using correlation between relatives. So before actually estimating heritability using this method, I would like to give you an overview about this method. So first I will talk about the relatives. Relatives can be divided into two categories. The first type of relatives are known as direct relatives and the second type of relatives are known as indirect relatives. Parent and offspring are known as direct relatives. They are called so because offspring directly receive genes from the parents. So that's why they are known as direct relatives. So if you have data on direct relatives, for example data on parents and offspring, you can use this data to estimate the correlation coefficient, and on the basis of that you can also estimate the heritability. So first we will see, if we have the data on one parent and offspring, we can estimate the correlation coefficient between one parent and offspring, and then we can estimate the heritability, which would be the twice to the correlation coefficient. So if we have data on both of the parents and the offspring, then we will calculate the mid-parent value. Mid-parent value is the average phenotypic value of both parents for a particular trait. So if you have the data on both of the parents and the offspring, then what will you do? You will calculate the mid-parent value and then you will find the correlation coefficient between the mid-parent value and the offspring's phenotypic value. And the correlation coefficient obtained by this method would be equal to the heritability. So now let's talk about the indirect relatives. Indirect relatives might be the sibs, aunts and uncles. So if you have data on sibs or cousins or uncles and aunts, then you can also estimate heritability using the correlation coefficient method. Let's say if you have data on sibs, then you can estimate heritability using correlation between the full sibs. And if you use this method, then the heritability would be equal to the twice correlation coefficient, because the genetic relationship between full sibs is 50%. And in case if you have data on half sibs, then you can also find the correlation coefficient between the performance of half sibs, and on the basis of that you can also estimate heritability but in this case the heritability would be equal to 4r. It would be 4 times to the correlation coefficient. So you can estimate heritability using correlation coefficient if you have data on direct relatives or indirect relatives. In this video I will only provide you one example, that is the estimation of heritability using correlation between one parent and offspring. And this similar method can be used to estimate heritability using correlation between mid-parent and offspring, or correlation between full sibs, or correlation between half sibs. So let's see how can we estimate heritability using correlation between one parent and offspring. So to actually estimate heritability using this method, we need data on the phenotypes of a trait on one parent and offspring. So in this case offspring and parent are 50% genetically similar. It means that the correlation coefficient would be equal to half heritability, and it also means that heritability would be the twice to correlation coefficient if we use correlation between one parent and offspring method to estimate heritability. The correlation is denoted with small r, and we will use this machine method to calculate correlation coefficient. So now we will calculate heritability using correlation between one parent and offspring. So we will use this data to first calculate correlation coefficient, and then on the basis of correlation coefficient we will calculate narrow sense heritability. First I will give you an overview about this data. This first column shows the serial number. This second column shows average daily milk yield of dam, which I have denoted with X. This third column shows the average daily milk yield of daughter, and I have denoted this column with Y. So this 5 is the average daily milk yield of first dam, and this 10 is the average daily milk yield of this dam's daughter, and so on. So first we will calculate the correlation coefficient, and to calculate correlation coefficient we will use this formula. So I will make 3 new columns here. The first column is for x square, and in this column I squared up each value of x variable. As you can see, the first value of x variable was 5, so the square of 5 is 25, and so on. Likewise I also calculated y square. So the first value in y variable was 10 and its square is 100, and I squared up all of the values of the y variable. This last column is the product of xy, where I multiplied x value with the y value. So the first value of x was 5 and the first value of y was 10. So 5 into 10 is equal to 50, and I calculated product of each value of x and y variable using the same method. Now I have calculated x square, y square and xy, but we also need sum of x square, sum of x, sum of y and n. So we will also calculate these things. So here is n is equal to 5, as we are using the data on 5 dams and their daughters. So n is 5, sum of x is equal to 36, sum of y is equal to 39.5, sum of x square is equal to 274, and sum of y square is equal to 336.25, and sum of xy is equal to 288.5. So let's put all of these values into the formula. So you can see here I have replaced all of the values in the formula. Sum of xy was 288.5, so I have replaced it here. And then sum of x is 36, sum of y is 39.5, n is equal to 5. Here one important thing which you have to keep in mind, I have already told you in regression calculation, that this sum of x square is different with this sum of x. In this case we squared up all of the values of x and then summed up all of these values. So you have to write here 274, and here you will write the sum of x, which is the sum of all of the values of x variable, which was 36. So that 36 will be written here. Okay. Likewise, this 336.25 is the sum of y square, which I have taken from here. Okay. And this sum of y is actually the sum of each value within the y variable, that is written here. Sum of y is equal to 39.5. Okay. So in next step after calculation you will get these results, and afterwards after solving this equation you will get r is equal to 4.5 divided by 18.93. So after division the result of correlation coefficient is 0.22. So our correlation coefficient value is 0.22. Okay. So in next step what we have to do, as we are using the correlation between one parent and offspring, so in this case the correlation coefficient is equal to half heritability. When we are using one parent and offspring, the correlation coefficient is equal to half heritability. The heritability would become the twice to correlation coefficient. So now the formula of heritability becomes h square is equal to 2r. So as we have 0.22 correlation coefficient, so now we will multiply the correlation coefficient with 2. So h square is equal to 2 into 0.22, and our heritability estimate is equal to 0.44. So this was a very easy method to calculate heritability. I am sure now you can calculate heritability using correlation. If you find any difficulty in this method, please feel free to write me in the comment section. I would love to hear from you. And if you didn't subscribe my channel, please do subscribe it. Thank you.